Welcome to the training today titled Rubber Technology in Pinch Valve Sleeve Design. My name is Joseph Merzlak. I am the Director of North American Sales for Red Valve. I will be introducing my two colleagues here shortly. Before we get started, uh, please type any of your questions in the chat box and myself or Bruce or Tim will answer them at the end. So I'd like to introduce Bruce Platucci and Tim Bernhardt. Bruce, go ahead.
Hi, this is Bruce Platusik. I'm responsible for Red Valve Engineering, and it's actually been a pleasure to work at Red Valve with these valves. I think you're going to gain a knowledge of a really new and interesting technology.
Go ahead,
Tim?
Tim.
Yeah, hi, this is Tim Bernhardt, Design and Applications Engineer with Red Valve, focusing on the Red Valve side of the product line. I work under and closely with Bruce. So yeah, hopefully you all enjoy this training here and you can learn a few things about Red Valve and what we can offer to you.
Thank you, Bruce and Tim. And you'll hear these two during the course of the presentation. They will jump in with their comments when they feel that some additional color needs to be added to the presentation. So we're going to begin, but before we get in earnest to the presentation, I'd like to walk you through a little bit of the history of Red Valve. And I think you can all see the first slide on the screen. Red Valve was incorporated in 1953 and founded in Carnegie, PA by a gentleman called Spiros Rathis, who was a degreed engineer from the University of Pittsburgh, mechanical, with a mechanical undergraduate degree from that institution. From 1953 to 1973, Red Valve manufactured pinch valves exclusively for the mining, power, and pulp and paper market, and for ash slurries, and different aggressive processes. In 1970, so for 20 years, that's all Red Valve did. They were in heavy industrial market. But in 1973, with the advent of the Clean Water Act and recognizing a market opportunity, Red Valve Company diversified its products into the municipal wastewater market. The next big milestone was 1984. Red Valve introduced the soft seat elastomer ductile technology to the municipal wastewater market as an alternative solution to those traditional hard-seated backflow prevention products called flap gate valves. In the 90s, Red Valve introduces several variants to the original TF2 and Series 35 designs. We come out with the flat bottom TF1, the Series 35 one, inside the pipe 37G, flange 37, Series 39, which are inline cast iron check valves, which employ a duckbill check valve inside the body, and the 2633 mini flex. We also introduced curved bills to the design, thimble plates, inserts, and tandem tie flex arrangements. That was all in the 90s. In 1998, Red Valve launches a program, develops and introduces the coarse bubble and its aeration and hydraulic mixing products. This was our effluent diffuser products and dirty water aeration products into the wastewater market. In 2001, Red Valve comes along again and introduces another innovative product, the passive mixing system, or for finished water tanks, to the water market. 2009, we introduced the inline checkmate valve, which is the lowest head loss valve, check valve on the market. In 2010, Red Valve develops and introduces the hydraulic recirc mixing. This is dirty water mixing into the wastewater market, much like the finished water mixing, but exclusively for dirty applications. 2016, Red Valve was acquired by Hillenbrand. In 2017, we enhanced the check inline. It's selling so well. We introduced an enhancement to the Checkmate UltraFlex, and we increase its performance by lowering the head loss 35 to 40%. And the latest milestone in 2021, Red Valve was acquired by the Zurich company, becoming one of the family of products. So we'll take you down the road here now. We'll start out with traditional valve styles versus pinch valve technology. So the question I get a lot is in presentations when we're doing lunch and learns, when should pinch valve technology be considered? Well, we have a lot of, as you may know, we have several Zurich reps, which were our Red Valve representatives before the acquisition. And over the years, I've quizzed several plug valve representatives, and this is sort of the rule of thumb that I use in presentations. So 1 to 3% solids, you could probably use an eccentric plug valve and be okay. 4 to 14% solids, full port plug valve and still be okay. But once you hit that 15% plus solids, you may want to look at a soft seated type of technology, a pinch valve. With, as you get up higher into the, heavy solids processes. Another consideration would be low or no maintenance areas in a plant or collection system. I know in the Midwest, I did a lot of work in lagoons, isolation valves in lagoons. A lot of times those valves rarely get exercised. So a pinch valve can stand alone and have no maintenance for a very long time and still be functional. Throttling or modulating service on grit, sludge, influent process with abrasive content or heavy particulate like rags, branches, stones, are handled well through a pinch valve. Some problems with traditional valve styles, as you see here. All styles require regular exercise and maintenance. All styles have some kind of mechanical component in the flow path. All styles are susceptible to collection of solids around the mechanical components. All styles are susceptible to scoring, damage to the seat from flow media, causing the valve to bypass flow or not completely seat for 100% shutoff. All styles, if not properly maintained and exercised, will be affected by increasing torque values over time. That's why a lot of times you see long cheater bars in wastewater treatment plants or industrial plants. What has happened to those valves is the torques have increased over time due to filing, and the operator is trying to gain a mechanical advantage and turn that valve. And oftentimes, when the torques become too great, what happens? They end up shearing the stem and damaging the valve. It becomes non-functional at that point. So here you go. Here you can see some traditional valve styles that are used in across industries, wastewater, whether it be wastewater treatment or industrial applications. Up in the top right, you have your ball valve, you have your plug valve, in lower left, you have your butterfly and your weir diaphragm valve down in the lower right. Now, when I'm doing this presentation, we're comparing pinch valve technology as we move forward with standard metal seated, plain Jane, whether it be a ball, a plug, a butterfly, or a diaphragm. Obviously, when you start getting into exotic alloys and whatnot, there are different wear values. However, the price of the valves go up significantly the more exotic you get. So when I talk here, we're just comparing your standard standard valve, standard construction. So traditional valve wear. When abrasive particles strike the hard surface of a traditional metal valve, the energy of the impact is completely absorbed by the metal surface, prematurely wearing seats, weirs, rotating discs, plugs, and balls. Additionally, these abrasive particles pack behind the ball and plug, scoring the sealing surface and creating leaks, what I had just said earlier. This is the pinch valve concept. When the valve is closed, it's a class, depending upon the valve, a class 4 or class 5 shut-off valve. As the valve begins to open, anything that has agglomerated to the sidewalls of the valve begin to flake off and flow downstream. And when the valve is completely open, if it's a standard full port sleeve, it's the same ID as the adjoining pipe. So the theory behind soft seat technology or pinch valve technology is when abrasive particles strike elastomer surfaces, the impact is absorbed, then deflected back into the particle. Extremely resilient elastomers wear at far slower rates than ceramics or metal alloy valve trims. Pinch valves are full ported with no crevices, packing glands, or seats to valve drawing operation. So the pinch valve is the heart. The sleeve is in all pinch valve technology, whether it's ours or a direct competitor, the valve trim or the sleeve is the heart of a pinch valve. So I'm going to give you a little brief overview. Basically, there are 3 parts to a pinch valve sleeve and its construction. Mainly, you have the smooth inner layer wear rubber. Then you have the secondary layer, the mid layer, which is the bias ply fabric reinforcement that gives the valve its strength to house pressure. And then you have the outer wrap. So no matter what material that you have, the construction will be similar. Now, when we get to high pressure sleeves, we up to 720 psi, we do have to add some heavier nylon wrap, maybe some Kevlar to add strength to the tube. And I do want to point out that we got this sleeve trim up here right now. Pinch valves up to 8 inches carry the standard ANSI face-to-face dimension. Over that of 10 inches and up, pinch valves carry a longer face-to-face, no matter if it's the red valve pinch valve or a competitor's pinch valve. The extra length in the tube is required. The material, extra length to make up the sleeve is required. So during the closing and opening process, you do not stress the you don't stress the corners of the valve where the tube meets the rubber flange. It's an integral part, but that's the weakest part of a pinch valve, is where the tube meets the flange. Therefore, the pinch valve sleeve is made longer in sizes over 8-inch to accommodate for the stresses. What you're looking at here is a standard pinch valve sleeve trim. Great care is taken to match the specific elastomer pressure rating and temperature limits for each application. Full port sleeves provide uninterrupted flow like another piece of pipe, and flow remains streamlined and laminar when throttling. So even when you're starting to throttle a pinch valve, it does remain the flow remains in a laminar state. What you see here is our cone sleeve trim. This trim goes out probably in about probably 85, 90% of our throttling and modulating control valve applications. What we're doing with the trim is trying to accommodate or match the flow in the pressure drop to dial in on the sweet spot of the control range to give you a nice turn down. So again, when you're working with throttling or modulating applications, you're going to see this trim probably being offered in a lot of those in a lot of those applications. This is our double wall sleeve trim. This is mainly found in your industrial applications where you have heavy solids loading and higher velocities. A lot of times in mining applications, power applications, bottom ash, fly ash, scrubber applications, you'll see a double wall trims. And this is our high pressure sleeve trim. Built somewhat like the other trims. However, we do add some stronger material when we're talking about this sleeve trim. We don't, I would say we don't, I don't see this sleeve trim or a high pressure valve sold much here domestically, but we get a lot of RFQs and inquiries from our regional manager and from our representatives down in South America in the mining applications. So we're gonna now walk through the first two products, the air-operated pinch valves, our 2600 type R type A, and MegaFlex products. We're going to talk about those a little bit, and then we're going to do an application review. So this is our type A air-operated valve. This is probably the simplest form of a pinch valve. It is air-operated. What you're doing here is you're building, and you'll see in the animation that comes up next, you're building air pressure in the actual casting. The casting acts as the actuator. You're building about 35 PSI over the line pressure inside that casting, and which causes the differential pressure, causes the sleeve to collapse and seal. We can offer both full port and cone sleeve trims in this valve. We offer sizes 1 to 28-inch in a split cast design, 150-pound drilled flanges. You can see all the elastomers that we offer. And we also can do this valve in a cast aluminum, split body cast aluminum. You do gain maybe in the larger, some of the bigger sizes over 10-inch. If you're hanging in a or if you're installing the valve in an overhead installation, aluminum is a little lighter. So basically, you're going to look at this animation and you're going to see how the valve functions. You'll get a better feel for this when you, after watching this short video. And by the way, there is no sound. The next is, again, this is another version of it operates the same as the Type A in the video you just saw. It's the 4700 air-operated pinch valve. Now, this is not cast aluminum. This is a spun aluminum body with a sleeve in it, right? Whether it's pure gum, neo, hypalon, chlorobutyl, buna, Viton, or EPDM. However, I would caution you here that if this valve, if the selection is made for this valve, you probably will want to use some kind of a backing ring on the back side of the aluminum flange. Sometimes you can distort. The aluminum is thinner. Sometimes you can distort the aluminum. And this is our Mega A air liquid or air operated pinch valve. This comes in sizes 30 through 84 inch. Standard offering is a carbon steel construction. We could potentially make this valve up to probably 100 inches, a little over 100 inches. Our largest Type A valves, you'll see here shortly, were sold and are installed at the city of Indianapolis in their CSO system. Again, body functions is a built-in actuator. It requires about 30 to 35 psi over the line pressure to close the valve. When you're looking at valves of this size, a lot of times clients will specify an opening and closing time. So there's a little bit more engineering that goes into these valves as far as calculating the number of air ports required to fill the valve and the number of exhaust ports to exhaust the air in the valve. Where sometimes we're asked to help size the compressor. We do have standard volumetric calculations that we can provide to the customer. We really would like them to take the responsibility and select a compressor themselves. Bruce, I'm going to let you make a comment. You know, anything else you can think in these larger valves sometimes that can be considered as far as application data or things that a person might run into when talking about these valves?
One of the important things is the flanges. We typically step up the flange size to a larger size in order to accommodate the thicker sleeve and the additional body. But that really isn't a problem because of the pipelines that these are going into. You know, there's steel pipelines and the flanges are typically welded. So we can certainly help walk the customer through that.
Thank you, Bruce. I didn't mention it before, but I'll mention it now. Our standard finish here is enamel finish on our valves. We can offer epoxy and even fusion bonded finishes. However, I will tell you that fusion bonded epoxy finishes, powder coat can, there are a lot of offerings out there. So the paint spec has to be very specific. Bruce, you want to make a comment on that while we're on the topic?
Yes, the one of the things that's becoming more and more prevalent in industry is for the epoxy companies would like the customer to suggest what type of service they're going into, as far as the degree of severity, and if it's going to be submerged. And there are ANSI specs out there, and it's basically ANSI NACE, and there are ISO specs that categorize all these various applications, and they all end up going all the way back to when the valve is sandblasted or grit blasted. is the first step in order to prepare the surface of the metal for the coating. So we may come back to you with that, saying, what class of finish and durability is needed by the application. Durability is another issue, whether it's a 5-year, 15-year, or 40-year durability. That's going to necessitate 3 different types of coating. Might be the same paint, could be the same paint or the same epoxy, but invariably it's going to necessitate more coats, thicker coats, and perhaps an overcoat.
Thank you, Bruce. This is so we can get very large or we can get very small in these type A valves, or this is the 2600 mini flex. This is comes in carbon steel or stainless steel, and it is an NPT connection. And this sleeve here, unlike the other sleeves we talked about in the type A, this sleeve is a molded sleeve and not a hand laid up sleeve. It doesn't have any nylon in the construction. It's offered in pure gum, EPDM. You can see all the elastomers on the right there. This valve is a lot of times used for sampling lines and whatnot. Some, maybe filling lines in an industrial plant where they're maybe have to fill bottles or products. Maybe liquid soap in a bottle measures it out, and it's a great little valve for those types of applications. Don't see it too much in the municipal market. A lot of times this valve is seen. We see it a lot with OEMs or on the industrial side. And here's another one. Here's our Type R air operated pinch valve. This is very, very basic, right? So it's a rubber valve. But Bruce, you want to just talk about the construction here? There's like a void area inside when they manufacture this, correct?
Yes, it's like a hose within a hose.
Okay.
And the ends are joined together between the 2 different layers of hose, and that forms that gap in between them. The connection that you see at the top is a Schrader air valve, like on your tire for your car. And this is where you put your air in and you let your air out. And the air accumulates between the layers and closes it just like a Type A. So, in that regard, it's just like a Type A. You will need on your piping system, you need to ensure that your piping is supported and mounted so that the pipes don't move apart and then slide out of the clamps that are on there. So that's about the only caution. There is a caution that applies to this valve and to the previous valve, the 2600. You might think that applying more air pressure will close the valve off tighter or more tightly. In effect, what it does, it shortens the life because that additional pressure, it'll tend to blow that inner sleeve out the end of the valve, just like as though you were inflating a balloon. You do need that restriction or that counteracting force from the line pressure to stop that. So increasing the pressure is not good in these types of valves. Your closing pressure should be adjusted so it's just enough. If you're using 50 PSI, you dial it in so that maybe you can get away with 60 or 70, depending upon the elastomer. And over time, the elastomer will work itself in and it'll soften. And that will allow the customer to further reduce their air pressure, their closing pressure, in order to maximize the life.
Thanks, Bruce. One other comment. you will need to provide, when ordering this valve, the exact pipe OD, since it's a slip over the pipe valve. With our Type A air products, we supply all the additional or the following options and accessories. We can supply a three-way, ASCO three-way solenoid valve with the Type A. We don't usually, very rarely do we supply that. The customer usually supplies that, the end user. But we have access to it, and it's part of the options package. We can also supply adjustable booster relay options. Fairchild Model 21 is our standard, what we offer in the price book. Filter reg sets, which is the Fisher Model 67 CFR. We have that available. The Series 700 fail-safe package. Bruce, why don't you comment on that? I guess talk about maybe the based on the size of the valve, the sizes of these all the fail-safe packages aren't the same size.
The fail-safe package is required when the customer fears that he's going to have a loss of air on his system, and he wants to ensure that the valve stays closed. So basically what you do, or what is done, is that an air tank is an air accumulator tank is installed to the valve, and in between that accumulator and the valve is installed the control valving. Whenever the air supply, air pressure drops off to the unit, we have another valve in there that allows that accumulator to provide pressure for the valve to operate. Those tanks obviously have to be sized to match the size of valve that's involved, and also the number of times the customer wants this valve to operate after loss of air. For example, if it only needs to operate once, that'll be one size of package. If they want it to operate 3 times or 10 times or 12 times, then you need a bigger accumulator to match the requirements. So that's easily done and accommodated as long as the information's provided up front.
Thank you, Bruce. Like I said earlier, we do offer fusion bonded or epoxy coated finishes. And lastly, we do offer this in AIS compliant construction, which is, as you know, in the municipal wastewater market here in the United States, is nowadays very important. We just talked about the fail-safe air packages, standby systems. These can be designed like as Bruce said earlier, for either type A's or which we'll explore tomorrow, Series 5200s. Does not replace any operating components that are in the system. Air is stored in the tank, and air is emitted to an actuator via a 3-way pilot or solenoid valve, depending upon failure mode. Some of the applications that we see with the Type A or Mega A, grit line or grit removal, raw water intake. Actually, I've seen a lot of large Type A's in raw water intake applications. Sludge lines, cyclones in mine tailings out in the Southwest, and we've seen them used on cyclones out there. Waste activated sludge conveyance, cement conveyance is a very big application, at least Red Valve's involved in. We've done a couple of dry cement plants for conveyance of the powder. Remediation, CSO inline wastewater storage. This project we're going to talk about here shortly. We've used this in inline storage out in Indianapolis, and actually CSO flow diversion. We had an application out down in Tempe, Arizona, where we employed these valves in a flow diversion application. Now
Joe,
I'm sorry, go
if-
ahead, Bruce.
if I could jump in on that application information,
Sure.
and excuse me for doing that. There's one that was extremely interesting to me. If we talk about abrasion, we had an application where glass shards were being conveyed into a glass melting operation. These valves were used to control the flow of the glass shards. You know, it was, and they did well. They definitely held up to the service. So that was one. If you're at all concerned about the valves being abrasion resistant, you know, give them a shot. Let your customer have an opportunity to look at these valves. And lastly, the only caution that I have with the type A's, it's any of these air operated valves, is they shouldn't go into vacuum service. For example, on pump inlets, the vacuum essentially sucks them closed. So unless you have vacuum, a counteracting vacuum that you use is your negative air pressure to hold them open, they'll definitely make a problem in your system. So don't use them on the pump, on the suction side of the pump. Thanks, Joe.
Thank you, Bruce. Next, we're going to walk through the Series 7570, 9000, and 52H. These are our manually operated pinch valves. We're going to talk about the valves, some application or accessories and options and applications. I promise we will get to some pictures and we will get to some applications here. So the Series 70 and 75 are basic manual pinch valve. The 70 is a fabricated steel frame. The 75 is a cast iron construction. The advantage to the Series 75 is the fact that we can make the laying length of the valve, because it isn't a fabricated body. We can make the sleeve not shorter, but longer if need be. So that valve can be offered again as a special with a longer sleeve if required. The Series 75, again, up through 8 inches. It's a drop-in replacement for standard ball or plug valve. So in retrofit applications, the question is always asked, well, if I use a pinch valve, will I have to repipe? Not up through 8 inch. You will not have to repipe. For the Series 75, the standard construction is a cast iron body. We can do a cast aluminum body. We haven't done a lot of that, but it is available. The standard, drilling here is 125, 150 pound flanges, and we do offer other drillings as well, as you can see there on the data sheet information. This is the 75B. So it's a manual pinch valve. However, it's used a lot for, as it says, 75B stands for buried service. When I say buried service, that does not mean submerged service. It's earthen buried. Comes in a cast iron body. It's sealed. Has a torque tube. Usually it comes with a devil gear. The manual version obviously can come with a hand wheel, or in some cases, it could also come with an A nut, but I would doubt you would use that. You may, if you have a miter gear that you install to bring the A nut into a valve box. Again, heavy duty construction, we use a coal tar epoxy equivalent here. Coal tar epoxy itself is, I guess, no longer able to be used due to regulatory issues. 150-pound flanges. Bruce, do you have any other opinions or comments on this valve?
No, it's a good rugged valve. That's
Thank you.
we even see it come with a position indicator on it that'll count the turns for open and close. But it's a good rugged valve. You know, it's you put them in and you forget them.
Thank you. Yes, I've used this again, this was the valve that I've used out in the Midwest. Several end users, several engineering firms have specified this in lagoon applications, again, where there is hardly any human interaction with the valve. Since the tube is the only wetted part and houses the process, there is no way for the process fluid to get up into the mechanical mechanism. So that valve could be in the open position or in the closed position for several years, and the operator would be able to go up and spin that valve open or closed. As Bruce alluded to before, rubber does take a set. So if the valve is throttled or is closed for a long period of time, we attach, and we'll look at this in the accessory and options here a little bit later, but we attach positive opening tabs to the sleeve, which help mechanically open the valve if it's been closed for a long period of time.
Hey, Joe.
Yes, Tim.
Can we hop back to the 75B just for a second? I don't think it was mentioned, but it's good to keep in mind that torque tube, that extension, that vertical column between the valve and the bevel gear or the straight hand wheel operator, we can provide that in customized lengths. And the way that we measure the length of that tube is from the center line of the valve of the sleeve to either the axis of the hand wheel if it's a bevel gear, or if it's a straight hand wheel, to the top of that hand wheel. So it's from the center line of the sleeve to the actuator. And like I said, we can offer that in customized lengths to fit, the height that's required by the customer to come above ground, above grade, so that it can be operated, whether it's direct buried or if it's in a valve vault or box. But that's an important aspect of this 75B to keep in mind, is that customized length that we're able to provide. So it can be versatile to fit, different depths of buried service.
Thank you, Tim. This valve is, again, another great application for this valve is landfill leachate, where traditionally they may use a plug valve or a gate valve. A lot of times there's a lot of crud coming down those leachate lines, a lot of sticky material that can file a traditional metal seated valve. Pinch valve, a 75B buried service valve, works great in those applications. This is our Series 9000 high pressure pinch valve. I'll be honest with you, I haven't, in my 20 years here, I've sold a couple. I did sell some high pressure 9000s to the Santa Rosa Biosolids project out in Santa Rosa, California. They were pumping dewatered sludge at 280 PSI. So we sold some valves in that application. Ductile or stainless steel bodies can be supplied. We offer several bevel gears based on the rim pull required in these higher pressure applications. Available in Pure Gum, Neo, Hypalon, Chlorobutyl, Viton. Again, this is a true 300-pound class valve with 300-pound flanges. Bruce, do you want to give a little, feel to give a little more color on this product?
You know, this is one of the ones where if you need it, this is the only option, especially when you get above 150 psi. It's another one of those valves where, you know, it's rugged enough you can just put it in and forget it. There's no special care needed, and we can also provide ISO flanges, ISO drilled flanges for. Um, we can accommodate that, and by and large, it's, you know, put them in and forget them.
Thank you, Bruce. So in the sleeve construction, we will use higher strength materials to get to the pressure required, but the valve is rated up to 720 psi. Manual pinch valves, features and benefits. We'll go over this briefly. Like we had talked about, same face-to-face as a Gator plug and some ball valves up through 8-inch. Just makes for an easy drop-in replacement for other valves and valve type for during retrofits. 100% full port, reduced head loss, better CV values across sizes than compared to a ball or plug valve. Bi-directional centerline closure, ensures drop tight shut off, no packing to maintain. So pinch valves, none of them require any kind of packing that needs to be set on the shelf. So no packing means reduced maintenance costs. You don't have to store any kind of packing, and you don't have to have an operator or a maintenance man repack the valve. Sleeve is only wetted part, which equals reduced inventory costs, self-cleaning, reduced maintenance costs. Now, I think the most important one, closing and opening torques remain constant over the life of the valve. So you're not going to get those increased torques, meaning that there's no cheater bar required, and which equals no sheared valve stems. Some of the options and accessories we talked about: bevel gears, floor stands, stem extensions, torque tube extensions, which Tim commented on earlier, chain wheels, stainless steel mechanisms, A-nut, 2-inch AWWA nuts, fusion bonded or epoxy coated finishes, limit switches, positive opening tabs, most importantly, ASI compliant. These are the positive opening tabs that I was talking to about earlier. And the positive opening tabs are actually vulcanized into the sleeve trim when it is being manufactured. And the tabs then are connected to the pinch bar. In this illustration, you're seeing that they are anchored with some sheet metal screws. We've now gone to nylon fasteners for the anchoring of the tabs to the pinch bars. This is an example of a Series 75 with limit switches, some Go limit switches. We actually slot the casting and then attach the limit switches in the target to the pinch bar. Larger diameter pinch valves, we do make a 52H, which in sizes, it's a manual. Basically, it's a 75, but we call it a 52H. Sizes 24, 30, 36, 42-inch, and 48-inch. We have a large manual valve installed in Ohio at a reservoir or a lake. It's used as a drain valve for when they dredge the lake in the winter. So we do have a large mechanical valve out there. We do have a couple, actually. Again, great applications are grit line and grit removal, sludge line, the Laguna isolation that I was talking to you about, stormwater retention basins, which we're going to look at. Airport glycol de-icing pads is a great application for pinch valves, manual pinch valves. Mine tailings discharge right at the dam. Waste activated sludge remediation, landfill leachate is another great application. So now we're gonna, if there, Bruce, do you have any comments on that before we get to the application review for the
No,
attendees?
I think you've done a great job, Joe.
So we're gonna first look at Gwinnett, Georgia Advanced Treatment Facility. In this, in this project, we supplied 109, and this goes back several years before I started at Red Valve prior. I think this was in the 90s, 192 inch, 2-inch through 12-inch 75s. We supplied 35 5400s and 148-inch series 39 check valve. But again, the series 75s, we supplied 192 of those in this project. Red valve pinch valves are used in waste activated and digested sludge service. This was another shot of that. As you can see on the right, there's some manual pinch valves there painted in blue. And then you can see the chain wheel operated isolation valves. And you can see a control valve on your left in the middle in the pipe painted purple. So you see the two valves that have the chain wheel operators on them. Those are manual valves. Orange County landfill. This was in a project I did with our representative down in Florida. We supplied 20 series 75s and one electrically controlled pinch valve. Again, this was like, I guess, a leachate storage tank. And you can see the pinch valves supplied here in red. Some of them did come with bevel gears, others did not. But it made for a very photogenic installation. Pinch valves, what's nice, as long as pinch valves are secured and anchored correctly in the pipeline, they can be put in any orientation in space within that pipeline, which means you can hang that valve. The hand wheel could be down if preferred. It's a 6 o'clock position. Again, this just more photos, images of the same project. The next project is the city of Indianapolis, Indiana. This was the combined sewer overflow project, which was done in 2002, 2003. I worked on this one as well. It was the real-time control early action program there with the city of Indianapolis CSO group. The engineer was Triad Engineering. The owner was City of Indianapolis, Indiana. The scope of the project was to identify a control strategy to minimize combined sewer overflow and frequency through the optimization of the collection and treatment system. They wanted to use a certain segment of their force main of their pipeline and their CSO system for inline storage. Project status, the startup was in 2003. These valves are still in operation at the city of Indianapolis. They were our air operated type A Megaflex valves that we talked about earlier. There were two 72-inch valves and one 66-inch valve. These were the road or the street names that these valves were located in. These are just a This is a map of the location. How do pinch valves fit the equation? Why did Triad Engineering want to look at these? Well, City of Indianapolis, number one, it was a proven technology, unbelievably cost effective. The City of Indianapolis, along with some other Northeast cities, they were using what was called inflatable dams to use for inline storage, right? To store rain events, wet weather events. And the inflatable dams, the installation cost and to maintain those dams was considerable. So Triad Engineering talked with the City of Indy and talked about supplying, since this was going into circular RCP, talked about offering the technology of pinch valves to take the place of the inflatable dams that the city was using. Inflatable dams, when they're down, do take up some pipeline or space when they're deflated. The advantage with the pinch valve was it was a full line size, right? So when the valve was open, it's the same idea as the pipe. Pinch valves provide the ability to regulate flow. In this case, they weren't really regulating flow. They were causing a dam or a weir. They were acting as a gate, a tide gate in effect. And ease of installation and maintenance. They were a lot easier to install in the vault than the inflatable dams. With the inflatable dams, there's a frame that has to be installed into the concrete. You have to lay the rubber down, and then you have to put the frame over top of the rubber to make the seal. So the pinch valves were much easier to install in the application. So in the City of Indianapolis, pinch valves are being used for two reasons. One, to improve the utilization of the entire collection system for inline storage in a certain part of the city for wet weather events. And the second consideration was the cost savings. The city recognized $450,000 savings per installation over the inflatable dams that they had been using. So they saved in this project about $1.5 million of installation costs. This is what the valve looked like on paper during design. And again, we were talking about very, very low pressures here, less than 1 PSI. It was a lot of volume, but very, very low pressure. This is the McCarty Street valve. These valves were buried underneath the city street in a vault, put in a vault. And the compressor station was located adjacent or on one of the corners of the street to operate the valve. This is what, now again, the photo is a little distorted, but because this was very low pressure, we used piping spools. This valve left our plant already. The piping spools were attached to the valve. The valve bolts were all torqued to the correct values. So all the contractor had to do is lift the valve off the truck and set it in the vault. I talked to our representative, BL Anderson. It took the contractor, there were 3 valves. The first valve took about 8 to 10 hours to install. The other 2 valves took about 2 to 3 hours. So once they were able to install the first valve and work out all the kinks, the other 2 valves went very quickly compared to the inflatable dams. This is the valve. They used some dresser couplings here to make the connection. Again, because this was so low, such low pressure, they were able to make that kind of connection versus a hard flange connection. We, in this, with this valve, there were closing and opening times required, so we had to calculate the number of airports required, the size. We helped we actually supplied the compressor and the controls with these valves. We very rarely do that, but in this instance, we did do that for this project. Another shot of it looking down. City of Indianapolis, actually, their Clean Streams program actually won an award for pinch valves being used in a CSO application. Both the engineer and the city won this award, Triad. We're going to move now to Whitney Ranch, California. The engineer, this was for some 75 Bs, direct buried pinch valves. TLA was the consultant. City of Rockland, California was the owner. They were using gate valves to capture the first flush or isolate the first flush in weather-related events. And over time, the gate valves were collecting grit and solids in the seating area. So in this project, the consultant, we did a presentation, and the consultant wanted to explore using pinch valve technology versus the gate valves that they had been using. We ended up, there were 3 projects. We ended up, all 3 projects were complete by December 2005. As you can see, project 1 had 2 24-inch direct buried pinch valves with torque tubes and a bubble gear. Projects 2 and 3, you can see here, they were also 75 Bs. 5 additional projects to be completed in the first and second quarter of 2006. So there were a total, after these first 3, then there were another 5 that came along as well using pinch valves. Each project will consist of 2 buried service pinch valves with a minimum diameter of 16-inch. So this was a very great, nice application for red valve here. So think about pinch valves in these types of applications. This is what, again, the valve looked like, preliminary sales or sales order approval drawing. This next project, again, were some Series 75 Bs, was with the U.S. Navy. The owner was the Department of Navy. The engineer was the Navy engineers. They wanted to stormwater runoff isolation valves to isolate the storm lines in case of a hazardous chemical spill. So they were using these as isolation valves from in an area, I guess, where they offload chemical, right? Red valve is the basis for specification. At the time, the project bid in March of 06, we did end up getting this order. There were a 16 and 24-inch Series 75B and 130 and 36-inch 52H. That's that 52 manual buried pinch valve we talked about. This is interesting. So what they had was a torque tube. If at the top of the valve you see the torque tube, there was a bevel gear, and then there was a right angle miter gear that came into a curb box. So they were going to use a 2-inch AWWA nut with a T handle, I guess, to open and close the valve. This was even, there was no torque tube on this one. This was very near the surface, but it was still, this valve might have went in a lull, actually. Again, this was the other valve. This was the 30-inch 5200 H buried service valve for Pearl Harbor. And then the 36-inch. Very nice project. Again, we had to, we had to make sure we modified our standard specification for this project. I had to write at the time we didn't have it, a 5200 manual buried spec. So we modified our specification to limit the competition on this project. Moving to the next project, this was a City of Tempe, Arizona, CSO diversion valves. This was the one I was hinted at earlier in the presentation about CSO diversion. This was DS Williams was the engineer. Our representative at the time was Westech. This was for the City of Tempe. And they used two 48-inch Megaflex air-operated pinch valves and one 75B. The 24-inch 75B was the crossover valve in the system. We offered 2 Megaflex with a controls package. Again, we did the controls back in 05 for them, and one 24-inch 75B. As you can see in the diagram, the two main lines, one going to the 91st Street wastewater treatment plant, had a 48-inch air-operated pinch valve. The other 48-inch pinch valve was on the waste going to the Kyrene wastewater treatment plant. So when one treatment plant couldn't handle the flow, they would, divert the flow, close the 148-inch pinch valve, divert the flow through the 24-inch 75B into the other plant. These valves are still functional today. This was the control system with the compressor in the control vault. Yeah, this was the installation. The supply airline you can see is just a hose. It's not hard piped in the installation. We let the piping up to the consultant or the end user, whether they hard pipe it or use a flexible rubber hose or conduit. That's up to them. Here was the condensate drain line. This was the blow off valve in case they had to release air quickly. Again, the valve, I will tell you this, the valve took somewhat of a beating being installed. They marked the flow direction there, as you can see the arrow. Which this was a full ported valve. They didn't have to, but I guess they wanted to install it in a certain way. This is an interesting project using the City of Lafayette, Indiana, 5-mile force main. All these valves were used were isolation valves from Twickenham Boulevard to the Brady Lane extension. Hawken Environmental was the consultant. BL Anderson was the representative. This was for the City of Lafayette. 15 Megaflex air-operated pinch valves used for isolation valves. When, for work, when they had to isolate the line to work on the force main. As you can see, here was the scope of supply. This, was done over 3 years. 9 36-inch valves, 136. On Brady Lane, there were 5 36-inch Megaflex. Very lucrative for B.L. Anderson and for Red Valve. These were the sales drawings or approval drawings. This was, we again offered the some controls package on this. We didn't offer the compressors, but we offered the controls. That's what it looks like. And again, we obviously sub this out, subcontracted the controls out to a third party and incorporated them into our package. Now that we're done with the application overview, we're going to just touch briefly here on the competition. And when I say direct competition, when I talk about competition, we're going to talk about direct competition. Onyx, we go head to head with them in regional locations in the municipal market. They're entrenched regionally, some markets better than others. They have a very loose rep network. RF Technologies is another competitor that shows up in the municipal market. I see them out in California a lot. I see them on the East Coast, Chicago area. Again, they seem to be regionally entrenched. Some places better than others. LaRox, again, they show up in the industrial market. They're very tough competitors in our industrial market. We go head to head with them a lot in mining, in power, mining industry, and in power plants. And then Dual is a pinch valve company out of Canada that serves the industrial market. We see those guys in a lot of mining applications. And then one that I left off here is EVR. They are also out of Canada. And they do a lot in the industrial market, specifically the mining market. I will tell you that Onyx and RF Technologies, Onyx just in the last year has stated that they can do AIS valves. Prior to last year, they were having problems with that requirement. RF Technologies, we're not sure. We haven't been able to really validate whether they can do AIS or not, but we know that Onyx can. FlowRox, like I said, we don't see those guys much on in the municipal market, and Dual, we never see those guys in the municipal market. And that wraps up the presentation. We have, hope you enjoyed it. I hope it was, you learned from it. And you can view this again. It will be posted, I believe, through the Red Connect. You'll get more information on that. And I guess we'll answer there's 13 questions in the chat box. Myself and Bruce or Tim will answer your questions now.